graders, it's Mrs. Trembley. This is the second part of lesson 2.2, so 2.2b. And this time we're going to add and subtract fractions. Last time it was decimals, this time it's fractions. And again, you might be thinking, I already learned how to do this, and it's been in our skill packets too. Yes, that's been purposeful. In math, everything kind of builds on everything else. So you've already learned how to add and subtract fractions. Now we're going to learn how to add and subtract fractions that contain negative values. So this first section here, it's just a remember section. This is just to kind of trigger what you already know so that we can apply it to what we don't already know in just a moment. So take a look here. I have 4 sevenths plus 1 seventh. I'm hoping that you remember when you're adding fractions, first off, you have to have a common denominator when you're adding fractions. This one's great. I already have a common denominator. And you learned when you have a common denominator, all you do is add the numerators together, so 4 plus 1, and bring over the denominator. So 4 plus 1 is 5, the denominator stays 7, and then you have to ask yourself, is 5 sevenths in simplest form? Is there a number that goes into 5 and 7 other than 1? Because dividing it by 1, it would stay the same. And there's not, so we're done. Alright, take a look at this next one, and just because this is activating prior knowledge, don't worry about changing this just yet. If it was your first inclination to do that, that's a good sign, because I want that ingrained in your brain. But for now, just ignore that. I have 12/15 minus 3/5. When you subtract fractions, you also need a common denominator, and with this one, you don't have a common denominator. So we need to figure out a good common denominator here, right? I would like to pick the least or the lowest common denominator, personally, because it makes it so much easier to simplify at the end. And when I see 15 and 5, I know that 5 times 3 is 15, so I can easily change 3/5 into a fraction with a denominator of 15 by multiplying both pieces of this by 3. Because you learn to create equivalent fractions, you can multiply the top and bottom by the same amount. You could also divide the top and bottom by the same amount, but that's another conversation. Okay, so I want this common denominator. I'm going to make my common denominator 15. This first one's all set. To change this to a fraction with 15 as a denominator, I need to multiply both of those by 3. So 3 times 3 is 9. 5 times 3 is 15. So this right here is going to give me the same result as this. It's just now I have a like denominator, which is what I have to have. I have to have a common denominator. So just like addition, when the denominators were the same, you added the top and brought over the bottom. Now when it's subtraction, you're going to subtract the numerators and bring over the denominator. So 12 minus 9 is 3. Bring over the 15, and hopefully you're looking at 3/15 and thinking, 3 goes into both of those. So I'm going to simplify it. So the largest number that will divide into 3 and 15 is 3. That's how you simplify. Divide them each by that. So 3 divided by 3 is 1. 15 divided by 3 is 5. And bam. And if any of you are thinking, well, I would have really preferred to have divided this 15 by 3 and a 12 by 3 and had a common denominator by 5. If you thought that, then gold star for you. Very good. That's another way you could have done it. I'm trying to go with the way I think most people would. Alright, last one here of the prior background knowledge problems, then we get to do the new ones. I have mixed numbers, oh my goodness, that I'm supposed to subtract. Before you go finding a common denominator, because you do need one, I would suggest changing these to improper fractions, right? Because these are mixed numbers. So to make these easier to work with, we're going to make them improper for now. To make these improper, I'm thinking last year you learned a little half cloud, ma, right? So we make our little half cloud, and this MA stands for multiply and then add. So 6 times 3 is 18, and 18 plus 1 is 19. So 3 and 1/6 is really 19/6. Got it? All right, and then here I'm going to do the same thing. 3 times 1 is 3, plus 2 is 5. So that's really 5/3. So in both cases, you keep the denominator the same, you multiply and then add. Multiply and then add. And we're supposed to subtract those in the end. All right, now I need a common denominator. I'm hoping that the number 6 is jumping out at you for the common denominator, because 3 times 2 will give me 6, and we know that to create equivalent fractions, we're looking for numbers that we can multiply or that we can divide, but 2 is not going to go into 19 evenly, so don't even mess with that. All right, I'm going to leave this as 19/6, and then I want to change this, so I need to multiply them both by 2. 5 times 2 is 10, 3 times 2 is 6, and now we have a common denominator. We can go ahead and we can subtract. So 19 minus 10, that's what you'd need to do, and 19 minus 10 is 9. I'm going to bring over the denominator, and we're left with an improper fraction. So first off, I mean, you can divide into these first if you wanted to start simplifying that way, or I'm guessing most people would change this to mixed number first and simplify after, so I'll do it that way. 9 divided by 6. So 6 goes into 9 one time. There are 3 left over out of 6. And if you wanted to make sure this was right, then do half cloud mod to this result and see if you get the same thing. 6 times 1 is 6 plus 3 is 9. Oh, 9, 6, it does work. And in this, I'm hoping that you're looking at 3, 6 saying, that's not simplest form. Those are both divisible by 3. Or maybe you say, well, 3, 6 is equivalent to 1/2. However you do it, make sure that you write 1 1/2 for your final answer. Because, again, those are both divisible by 3. Or it could have been one of those benchmarks that you know. Okay, so there's our little background lesson. Now we need to apply that to the things that we are currently learning about in math. I want you to be able to add and subtract fractions containing negative values. So here are some steps to doing this. And the very first thing, I'm going to have you rewrite all of your subtraction as addition by adding the opposite. And after you've done that, you're going to want to change any mixed numbers to improper fractions. And when you have a negative mixed number, there's a little special thing I'm going to show you that you need to remember. I'll show you when we're doing the problems, though, because I think it'll stick better. Then, if we don't have a common denominator, you're going to write it over again and rewrite it using the least common denominator, or the GCF. No, that's not the one I'm looking for. There's another way to say it. But you're looking for the denominator that's the least common, meaning, or lowest common. I want it to be the first number that they have in common, not the last, because then when you simplify, it kind of takes a lot longer. Then we just use our integer rules. So I know integers are positive or negative whole numbers, but we can use those with fractions, and we can use those with decimals. And remember, if it's the same sign, we get to add those fractions and keep the sign. If we have different signs, we're going to subtract and take the sign of the higher digit. Bring over the denominator, simplify. Let's try it. Turn your page. Pardon me. All right. So if you wanted to, we could be flipping back and forth, but I'll kind of read the steps to you. First off, this is addition. I don't need to keep change anything, right? Second, I don't have any mixed numbers. I don't have to change that. Third, it says to rewrite if there's not a common denominator. There is. Excuse me. Now, number 4, use our integer rules to combine the numerators. So, see how there's a negative sign right there? When you go to add these together, we had had a discussion before about when you see the negative in the middle, it means that either the numerator is negative or the denominator is negative, right? I can put that negative with either one when I'm trying to do this, and you're going to want to pick. If you choose to put the negative with the 5, do you see how you don't have a common denominator anymore? Because 5 and negative 5 are not the same. So with fractions, when you're dealing with these, I would suggest that when you see the negative sign in the middle, you cross it out and you rewrite it in the top. You didn't change the value of anything. We're just picking a place for it so we don't forget about it. So now what this is really asking me to do is to take 2 plus negative 1 out of 5. So when you have a like denominator, you're supposed to add the numerators, right? And bring over the denominator. But now, because I have one of each, instead of adding, I'm subtracting those digits. So 2 plus negative 1, opposite signs, means I subtract and take the sign of the greater. So 2 plus negative 1 is 1. Bring over my 5 and see if I can simplify. And in this case, we can't, so we're done. All right, next I have a subtraction problem. And your first step says to rewrite as addition by adding the opposites. I'm going to go ahead and do that. This means negative 1/6 plus, that was a positive 5/6, now it's going to become a negative 5/6, right? I'm going to put the negative with the numerator spot, kind of like I did over here. So we just push the negative up into the numerator. Okay, so now I have a common denominator. It's addition. That means I'm supposed to add my numerators and bring over the denominator. Now in my numerator spot, I have two negatives that I'm adding, so I'm actually going to add those and keep the sign. A negative 1 plus a negative 5 is a negative 6 over positive 6. I can simplify this. Yep. We know that if we saw 6/6, it would be 1, right? Because 6 divided by 6 is 1. Now I have a negative divided by a positive, because these fractions are like little division problems, right? So when you do that, 6 divided by 6 is 1. A negative divided by a positive is a negative. So voila, negative 1. Doesn't get much simpler than that. You can't simplify that. All right, let's try a mixed number one, and this is subtraction. So your first step, the first thing you're supposed to do when you see subtraction is you're supposed to keep change it. So I have negative 3 2/3 plus negative 6 1/3. Okay, so now some of you might be thinking, well, I can do this quite easily. I don't need to change these into improper fractions. Just leave me alone. If you want to try it, go ahead. But I'm telling you, you're going to be less likely to make errors if you go ahead and change these to improper fractions before you start. That's a promise, right? So when you change these to improper fractions, that's what I'm going to do. Before you learn, you're supposed to take this times this plus that, right? Now there's this little negative sign here. When you're changing a mixed number that has a negative sign in front of it into an improper fraction, you need to ignore the negative sign and bring it back in at the end. And here's what I mean. Don't take 3 times negative 3. Take 3 times 3, which is 9, plus 2, which is 11, and bring in the negative sign at the end. If you took 3 times negative 3, you'd get negative 9, and negative 9 plus 2 is negative 7. Negative 7/3 isn't going to switch back into negative 3 2/3. So it doesn't work. You can't include that negative sign. So again, ignore it, bring it back at the end. Same thing here. Ignore the negative sign. 6 times 3 is 18. 18 plus 1 is 19. And that would be a negative. And I'm supposed to add those two together. So again, if you're changing a mixed number that's negative into an improper fraction, you need to ignore the negative sign while you're doing the half comma, and then bring it back at the end. Now as you look at this is great. It has a common denominator. This is addition. I'm adding same signs. So I'm going to take a negative 11 plus a negative 19 all over 3. So negative 11 plus negative 19, add the digits, keep the sign, bring over the denominator, and a negative 30 divided by 3 gives me a nice whole number. It's negative 10, because you learn that when you divide and you have one of each, the answer is automatically negative. All right, moving along. Of course, I had to give you some that do not have a common denominator, because what fun is it if they all have the same? I mean, I know everybody loves rewriting and finding the LCD. No, not really. I know, it's kind of a pain, but we'll work through it together. So 2/3 plus negative 3/4, it's already addition. I don't need to keep change it. I don't have any mixed numbers. I don't have to change those. I do need to find the first number that 3 and 4 have in common if I count by them. That's the LCD. I'm hoping that when you see 3 and 4, the number 12 pops into your head. If not, then maybe off to the side you would go 3, 6, 9, 12, and then 4, 8, 12, and then say, ooh, hey, the first number they have in common is 12. That's kind of how we're doing this. But if you know your multiplication facts, it'll go a lot faster for you. So basically, the first number that 3 and 4 have in common when I count by them, the LCD, is 12. So I'm going to ask myself, 3 times what is 12? Well, we can see here that it took 4 3s to make 12. So to change this fraction, I need to multiply them both by 4. So that would become 2 times 4 is 8. 3 times 4 is 12. Now to change this fraction into 12ths, I see that it takes 3 fourths to get to 12. So I'm going to multiply both of those by 3. So 3 times 3 is 9. 4 times 3 is 12. Do you see how that was negative? Put it with the top. Don't forget about that little negative sign. Remember we talked about in the first example, when you see the negative sign in the middle and you're trying to do this, just put it with the top. So now I have a nice common denominator. I see that I need to add the numerators. 8 plus negative 9. I have one of each. That means I have to subtract the digits. So 9 minus 8 is 1. I'm going to take the sign of the greater digit, which is negative. Bring over the denominator. We have negative 1/12. There's not a number that goes into 1 and 12 other than 1, so we're done. All right, keep moving. I have negative 5/9 plus negative 1/3. Okay, it's already addition. That's great. There's no mixed numbers. Great. But I don't have a common denominator. I'm hoping when you look at this, you're not going to say, ooh, 27. You don't need to make it as large as 27. I want the lowest one. If you count by threes, you can get to 9. 3, 6, 9, right? So I'm just going to change this fraction into ninths. This first one's fine. I'm going to put the negative with the numerator. Bring down my addition sign. I need to multiply the numerator and the denominator by 3 now, because I want to get an equivalent fraction. So 1 times 3 is 3. 3 times 3 is 9. There was a negative sign here, so I'm going to put it with the top. All right, so now it's an addition problem. It has common denominators. You just bring over your denominator, and we're supposed to add the numerators. So I'm left with a negative 5 plus a negative 3. When you're adding and you have the same sign, you add the digits, you keep the sign. So there you have it, negative 8/9. That can't be simplified because there's not a number other than 1 that goes into 8 and 9. Can you believe it? We're already at the last example. I know, probably felt like a torturous time for you. It's been great for me though, I gotta say. I just love this stuff. Anyhow, okay, this is subtraction. We said step 1, rewrite your subtraction problems as addition problems. I'm going to go ahead and do that. Negative 3 2/3 plus, that was a negative 2 3/4, now it's going to be a positive 2 3/4. Step 2 says change any mixed numbers into improper fractions. Yeah, this one's going to have everything. We're going to have to do every step. So when we're changing this negative 3 2/3 into an improper fraction, remember, ignore the negative for now. 3 times 3 is 9. 9 plus 2 is 11. So negative 3 2/3 becomes negative 11/3. Bring in the sign after. So 3 times 3 is 9. 9 plus 2 is 11. Bring over the 3. It was negative to start, so it's negative to finish. Now I'm going to change this. 4 times 2 is 8. 8 plus 3 is 11. And I have the 4. All right. So now we don't need common numerators, we need common denominators. So this isn't going to be helpful that those are both 11s. Don't let that trick you. I see 3 and 4, and we already had that. In this example right here, we know that the first number 3 and 4 have in common is 12. So oops, sorry, a little too high. So to change this first one into 12ths, I can take 3 times 4 to get 12. That means I need to multiply the numerator by that as well. So negative 11 times 4 is negative 44, and 3 times 4 is 12. To change 11/4 into 12ths, I need to multiply those both by 3. So 11 times 3 is 33, and 4 times 3 is 12. Now we have a nice common denominator, right? That's what we were looking for. Once you have that common denominator, I don't like this pen, I'll use this one instead, then you get to bring it over, or bring it down in this case. And I'm left with a negative 44 plus a positive 33. And I'm supposed to add those together. So we remember our integer rules. We have one of each. That means I need to subtract the digits. So 44 minus 33, yeah, that's 11. And you have more negatives than positives. So we're taking the sign of the greater digit there, negative 11. So negative 11/12 is already in simplest form, and you are finally done. I'll see you tomorrow.